Hi and welcome to MSc. In this video we're going to be looking at special triangles. Now there's two triangles that are really essential to memorize for high school trigonometry. And they come from the two triangles shown here. One is an equilateral triangle and the other one is an isosceles triangle that's also a right angle triangle. So let's dig into this equilateral triangle to start. So this equilateral triangle, what we actually do with this is we divide it in half and we only look at the one half. And that's the part that we key in on. So we can remember that it came from this equilateral triangle, but we're going to zone in on just the half of it. And when we do that, we get a right angle triangle that has an angle of 60 down here, just like all the angles in the equilateral triangle have. And the angle at the top corner here, it has an angle of 30, half of the 60. Now when we picture the equilateral triangle, all sides on the equilateral triangle are equal, and we're going to say each side has a length of 2. So that means in this right triangle I've created, it has a hypotenuse of 2. Because we've divided it in half, we have a base length here of 1. And using the Pythagorean theorem, you can show that the height of this triangle is the square root of 3. So it's actually this triangle, not the full equilateral, that is important to memorize for high school trigonometry. Specifically, what we want to do is we want to look at the sine, cosine, and tangent ratios that relate to both 60 degrees and 30 degrees. So let's start going through those and seeing what we can come up with. So let's start with sine. We'll start with sine theta. And we know that sine theta is opposite over hypotenuse. We will start here looking at the 60 degree angle. So let's say sine 60, because once we define sine 60, that locks in our opposite side. Our hypotenuse will never change, but it now locks in that we're dealing with the root 3 as our opposite side. So sine 60 is root 3 over 2. So that's the first one that will be important for us to know. Sine 60 is square root of 3 over 2. The next one that we'll do is cosine. And we know that cosine of theta is equal to adjacent over hypotenuse. And in this case, we'll say, well, the adjacent side, if we're dealing with cosine of 60, the adjacent side here is 1, and the hypotenuse is 2. So cos of 60 will be a half. That's the second one that's important to memorize. All right, moving right along. Let's look at the tangent of 60. So tan theta, we know, is opposite over adjacent. And again, once we lock in our angle at 60, then we can say, well, the opposite side is the root 3, and the adjacent side is 1. So we can not bother writing that denominator of 1 and just say that tan 60 is root 3. So that would be the third one that's important to know. All coming from this triangle above. Let's do the same thing now with the 30 degree angle, which will flip our opposite and adjacent sides. So we'll work through here. I'm going to say that sine 30, I'm not going to bother with the opposite over hypotenuse here. I'm going to jump straight in the interest of time, and we're going to say that the opposite side here is 1, and the hypotenuse is 2. There it is. That's the first piece here. Sine 30 is a half. Well, that's what cosine of 60 was. So it'll be interesting to see what the cosine of 30 is. So cosine of 30, we have the opposite, we have adjacent now over hypotenuse. So it's root 3 over 2. So they have switched their ratios. So at 60 and at 30, sine and cosine switch their ratios, which is interesting. Lastly, for this triangle, we'll do tan of 30, and this is opposite 1 over adjacent root 3. But we know we're not supposed to leave radicals in the denominator, so we'll rationalize the denominator by multiplying top and bottom by root 3. And this will say that tan 30 is equal to root 3 over, and I'll write this out, square root of 9, which then we can say tan 30 is actually equal to root 3 over 3. Okay, so all of that came from just using our primary trig ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. We have 3 trig ratios now for 60 degrees and 3 for the 30 degrees, all coming from being able to draw out this triangle. Again, the goal is eventually to memorize these so you don't have to draw out the triangle to create them in a test scenario. Moving over to the right isosceles triangle, we know we have a right angle there and these two sides are the same. Because we have equal sides and it's a right triangle, not only are these two angles equal, they both have to be 45. So those angles will both be the same. In this triangle, we assume that the height and the base are each 1, with then, based on the Pythagorean theorem, you can show that this hypotenuse in this case is the square root of 2. So let's repeat what we've done here for sine, cosine, and tangent, but now we're going to use just one angle, and it's going to be the 45. So we'll start up here, sine, and I'm going to jump straight in with the 45. It's opposite, and again, it doesn't matter which one I pick, the opposite side is 1 over the hypotenuse, which is root 2. And we know we're not supposed to leave radicals in the denominator, so we'll rationalize the denominator. And this will generate that sine of 45 is equal to root 2 over 2. Excellent. So that's another one we need to memorize now. We have 2 more to go. Let's look at the cosine. So cosine of 45, it's adjacent over hypotenuse, but again, it doesn't matter which 45 I pick. The adjacent side in each case is 1, and the hypotenuse is root 2. Well, that's the same as what we saw up here. So I know I can rationalize this denominator in the exact same way, and I'm going to get the exact same answer as above. Right? So we know that cosine of 45 is the exact same as sine of 45. It's going to be root 2 over 2. So that is the 8th one that we need to know. The very last one is tangent, and tangent of 45 is opposite over adjacent. So the opposite over the adjacent, or in the other case, it's still just going to be 1 divided by 1. And so tan of 45 equals 1. And that's the last one that we need to know. All of these show up in the unit circle. All of these come from these special angles, and they are used a lot, and we can evaluate all these trigonometric ratios now without the use of a calculator once we have these memorized. These are an essential skill here as we work through the high school trigonometry unit. I hope this video has been helpful. Thank you very much for listening and watching.